Hi guys, how you doing? Welcome back to the Unit 1 with the object-oriented paradigm. We look in the last video the object-oriented paradigm introduction, and we know some concepts about the object-oriented programming. And for now we are continue with the abstraction that it's about classes and objects and inheritance and polymorphism. We show these three topics in three different videos, but all of them are correlated. We start with the first topic, the abstraction about classes and objects, and we are using the UML class diagram. The UML class diagram is a graphical notation used to construct and visualize object-oriented systems. A class diagram in the undefined modeling language, that it's the acronym from UML. It is a type of static structure diagram that describes the structure of a system by showing the systems, and we consider the classes, attributes, operations, and relationships. This diagram represents classes, their definitions, and relationships. The classes and entities from the problem space are also detailed technical entities in the solution space. The attributes and operations that define the classes are included within this class diagram. Relationships in a class diagram illustrate how classes interact, collaborate, and inherit from other classes. Classes can also represent relational tables, user interfaces, and controllers. The purpose of the class diagrams is to show a static structure of classifiers in a system. The diagram provides a basic notation for other structure diagrams prescribed by UML. It's helpful for developers and other team members too, and the business analyst can use the class diagrams to model systems from a business perspective. And we are refreshing or looking again about what is a class. A class is a blueprint for an object. Objects and classes go hand in hand, and we can talk about one without talking about the other. And the entire point of object-oriented design is not about objects, it's about classes, because we use classes to create objects. So a class describes what an object will be, but it isn't the object itself. In fact, classes describe the type of objects, while objects are usable instances of classes. And each object was built from the same set of blueprints and therefore contains the same components like properties and methods. The standard meaning is that an object is an instance of a class, and objects have states and behaviors or actions. We have an example that a dog has states, for example color, name, breath, as well as behaviors like barking, eating, and walking. And an object is an instance of a class. In this case, Bobby is an instance or an object of the class dog. Now for the UML class notation, we need to know that a class represents a concept which encapsulates states, that mean attributes, and behavior or operations. Each attribute has a type and each operation has a signature. The class name is the only mandatory information for the class notation, and we can show that a class is or has three parts, or it's divided in 3 parts. And the first one is the class name. The name of the class appears in the first partition. The class attribute, it's that are shown in the second partition. The attribute type is shown after the colon, and attributes map onto member variables or data members in code. The class operations or the methods are operations that are shown in the third partition. They are services, the class providers, and the return type of a method is shown after the colon at the end of the method signature, and the return time of method parameters are shown after the colon following the parameter name. And operations map onto class methods in code. And we can show how the UML class notation can be drawn in the example in the slide. And now for the UML attribute and the object notation, we have a different parts that conform the a kind of pattern for the attribute and for the operation. For the attribute, we have the visibility, the attribute name, and the attribute type. And in the other hand, for the operation, we have visibility, the operation name, the argument name and argument type between parentheses, and finally the return type. For the UML notation or the UML notation for specifying attributes and operation, the notation is a well-defined language, which means that when coupled with a specific programming language, there is only one way to translate UML into a programming language, because it's very similar, the representation of the UML class notation to a class in a programming language. Then going from the UML to code is very simple and easy, and it's important to understand how you can conform a class in a diagram, because it's the same way you can programming this in a programming language. Now in the visibility of class attributes and operations, in object-oriented design, there is a notation of visibility for attributes and operations. UML identifies 4 types of visibility, that it's public, protect, private, and package. And we use the plus, less, pound, and tilde symbols before an attribute and operation name in a class, and that denotes the visibility of the attribute and operation. For the plus symbol, we are using it for the notes that an attribute or an operation is public. We use less symbol to denote private attributes or operations. we use pound symbol to denote protected attributes or operations, and we use tilde symbols that denotes package or default attributes or operations. And we can show in the slide an example about how we can use that symbols. To access for each of these visibility types is shown below in the table for members of different classes. When we use one of these symbols in different situations, for example, members of the same class, or members of the div class, or members in any other class, we have different access rights for every one of these kind of symbols or types of symbols. For example, if we are using the private symbol and we try to access a member of the div classes, we can do, or we can access directly, because this is one restriction in the access right. But if we have a public visibility symbol in an attribute or method, and we are trying to access from any other class, we can do it, because in the access right or the restrictions about using this symbol, it's that you can, or you have permission to use it in this situation, but depends about what attribute or what kind of visibility you use in an attribute or in an operation, and of where you are trying to access this attribute or method. And in the table you can show how the access rights are applied for everyone. Now we need to know about the perspective of class diagram. The choice of perspective depends on how far along you are in the development process. During the formulation of a domain model, for example, you will seldom move past the conceptual perspective. Analysis models will typically feature a mix of conceptual and specification perspective, and design model development will typically start with heavy emphasis on the specification perspective and evolve into the implementation perspective. And a diagram can be interpreted from various or different perspectives. The conceptual represents the concept in the domain. The specification focus is on the interfaces of abstract data types in the software. And implementation describes how classes will implement their interfaces. The perspective affects the amount of detail to be supplied and the kinds of relations worth presenting. As we look before, the class name is the only mandatory information, and then you can start with a conceptual, and you are growing up the class about, or when you have more information about what do you need in the attributes and methods to pass from conceptual to implementation. Because when you have the implementation perspective, you are near to pass to a code or codifying these classes, but you can use all of these three options. Now, in the relationship between classes, the UML is not just about pretty pictures. If used correctly, UML precisely combines how code should be implemented from diagrams, and a class may be involved in one or more relationships with other classes, and a relation can be one of the following types. We have the association, the directed association, the reflexive association or association, and multiplicity, aggregation, composition, inheritance, and realization. For the association is a broad term that encompasses just about any logical connection or relationship between classes. For example, the passenger and airline may be linked like in the example. The directly or directed association refers to a directional relationship that represents by a line with an arrowhead. The arrowhead depicts a contained directional flow. In the reflexive association, these occur when a class may have multiple functions or responsibilities. For example, a staff member working in an airport may be a pilot, the aviation engineer, a ticket dispatcher, a guard, or any other member in the crew. If for example, the maintenance crew member is managed by the aviator engineer, there could be a managed by relationship in two instances of the same class. In this class, for the airline staff, they related itself. In the multiplicity or cardinality, it's the active logical association when the cardinality of a class in relation to another is being depicted. For example, one fleet may include multiple airplanes, while one commercial airplane may contain 0 to many passengers. The notation out ... asterisk is the diagram means 0 to many. And for the multiplicity, we have some relationships or different way to express. For example, exactly 1, we just put the number 1, or we just describe with the number 1. In 0 or 1, we use 0.1. From many, we are using asterisk or just the asterisk symbol. 1 or more, we use 1 asterisk. Exact number, for example, the 3.4, or just use the 6 number. The complex relationship, for example, we can use O ... 1, a comma, and then 3.4, 6 asterisk will mean any number of objects other than 2 or 5. In this case, we just the 2 or 5 aren't in this relationship, and we can use one of these multiplicity in the diagram. From the aggregation, we refers to the formation of a particular class as a result of one class being aggregate or built as a collection. For example, the class library is made up of one or more books, among other materials. In aggregation, the contained classes aren't strongly dependent on the life cycle of the container. In the same example, books will remain so even when the library is dissolved. To show aggregation in a diagram, draw a line from the parent class to the child class with a diamond shape near to the parent class. To show aggregation in a diagram, we can use or draw a line from the parent class to the child class with a diamond shape near to the parent class. That is the part that you need to remember, because the composition is very similar to the aggregation relationship, with the only difference that being its key purpose of emphasizing the dependence of the contained class of the life cycle of the container class. That is, the container class will be obliterated when the container class is destroyed. For example, a shoulder bag's side pocket will also cease to exist once the shoulder bag is destroyed. To show a composition relationship in the UML diagram, use a directional line connecting the two classes with a filled diamond shape adjacent to the container class and the directional arrow to the contained class. In the last one, the inheritance or generalization refers to a type of relationship wherein one associated class is a child of another by virtue of assuming the same functionalities of the parent class. In other words, the child class is a specific type of the parent class. And to represent inheritance in a UML diagram, a solid line from the child class to the parent class is drawn using an unfilled arrowhead. And similar to inheritance, we have the realization that denotes the implementation of the functionality defined in one class by another class. To show the relationship in UML, a broken line with an unfilled solid arrowhead is drawn from the class that defines the functionality of the class that implements the function. In the example, the printing preferences that are set using the printer setup interface are being implemented by the printer.